So this is AVL tree. What is an AVL tree? An AVL tree is a self-balancing binary search tree. Self-balancing binary search tree. We know what is a binary search tree. So what is a binary search tree? A binary search tree is a binary tree that satisfies this property. That is called binary search tree property. So the left subtree of a node X, for example X, contains only nodes with a key lesser than the node, and right subtree of node contains key greater than the node. So this is called a binary search tree property. Okay. So this is an example of binary search tree, and I've given some values. For example, this is an example. So this is the height. Okay, what is the height of this tree? This is height is 3. Number of levels. Okay, so this is the height. Next, basically search. Okay, search in a BST depends on the height of the tree. So in this case, we can check, we can note it. It is almost balanced. Okay, this tree is almost balanced. So the search will take only log base 2n time. We know log base 2n algorithms are most efficient algorithms. Okay, but what is the problem of BST is that it is skewed BST. If it is a skewed BST, that is, for example, suppose you want to insert the data in this order 50, 40, 35, 30, that is in the descending order or in the ascending order, then the tree will be like this. So what is AVL tree? AVL tree is a height balanced self or self-balancing properties there. It's a self-balancing binary search tree. Okay. Okay. It is a self-balancing binary search tree. Okay. Okay. If any disturbance or any connection problem, please help me. Okay. Okay. So now. So what is so in the AVL tree, this is the property of an AVL tree. Okay, this is the property of AVL tree. In an AVL tree, the height of the two child subtrees of any node differ by at most 1 only. Okay, so if at any time they differ by more than 1, then we need to rebalance. Okay, so AVL tree works based on this principle. Okay, so we are defining a factor, balance factor of a node. So what is balance factor of a node? Height of right subtree minus height of left subtree. Okay. So the balance factor of a node should be -1, 0, or +1. If it takes other values than this one, then we should perform the operation rebalancing. Okay, so try to understand that concept. So next we are going to discuss insertion method. Okay, so before that we want to discuss this case. Okay, this is the insertion method and this is the insertion algorithm. And we can come back like to this insertion sort method. Okay, so now we are moving to check whether tree is AVL or not. Okay, we want to check whether the tree is AVL or not. How we will check a tree is AVL? How we will check a tree is AVL tree? First of all, it should satisfy BST property. It should be a binary search tree. Okay. If it is a binary search tree, then it may be, this tree may be AVL tree. Okay. This tree may be AVL tree. So how we can check this tree is AVL or not? What procedure we want to follow? Anyone? We need to get the balance factor of each node. If the balance factor of each node is -1, 0, or 1, then it is an AVL tree. Okay. We need to check the balance factor. What is balance factor? This is balance factor. Height of right subtree minus height of left subtree. Okay, and there is some correction, sorry. This is basically height of left subtree minus height of right subtree. Okay. This is actually the true. Okay, I written wrongly. Height of left subtree minus height of right subtree. Okay, please note that. Okay, height of left. Okay, left subtree minus height of right subtree. Okay. So we can check next. So this is our tree. You can start from the root. What is the balancing factor of this one? This node is height of left subtree, no left subtree, no right subtree. So it is 0. Okay, it is 0. Next, what is the balancing factor of 85? It is 0 because no left subtree, no right subtree. So it is also 0. Okay. Now, what is the balancing factor of 75? What is the balancing factor of 75? What is the height of left subtree? It is 1. Height of left subtree is 1 and height of right subtree is 1. 1 minus 1 is 0. Okay. So the balancing factor is 0. Okay. So now then, how we calculate the balancing? We will first take the left subtree height. Okay. Minus right subtree height. Okay. It's a very simple procedure. Okay. So note that left subtree minus right subtree. Okay. Height of left subtree minus right subtree is the correct one. So this is the balancing factor. It's also okay. Now, what is the balancing factor of this one? It's also 0. Why? Because no left subtree, no right subtree. Okay. Next, we will check this one, 50. What is the balancing factor of 50? What is the height of left subtree? It is 1. Okay. What is height of left subtree means 50 to 25. Only one path is there. So the height is 1. And the right subtree 2. This is the longest path. 2 is the longest path. So 1 minus 2 is -1. Is it okay? -1 is acceptable. Okay. Balance factor -1 is acceptable. Okay. So this also okay. In this way, we will check the balance factor of every node. Try to understand how to calculate the balance factor. For that, in this topic. Okay. So similarly, what is the balancing factor of this one? This is also 0. Okay. Similarly, the balancing factor of this one also 0. Why it's 0? No left subtree, no right subtree. Next, what is the balancing factor of 150? This node. This also 0. What is the height of the left subtree? 1. What is the height of the right subtree? 1. 1 minus 1 is equal to 0. Okay. So this also completed. Next, what is the balancing factor of 100? So the balancing factor of 100 is This is the left. Okay. What is the height? Height is actually this length. 1, 2, 3. That is longest path length is the height. So what's the height of 100 in the left subtree part? It is 3. Okay, it is 3 minus what is the height of the right subtree? This is longest path is 2. If we go in this path also, it is 2. So 3 minus 2 is 1. Okay, 3 minus 2 is 1. So this also, okay. In this tree, every node satisfies the balancing factor condition. So it is an AVL tree. If there exists some node that does not satisfies the balancing factor value, then we should do rebalancing. Okay, then we should do the rebalancing. Now let us check that situation. Okay, so for example, consider the below AVL tree. It's a very simplest case. For example, this is a tree 10 and 30. Okay, so now insert 20. So this is an AVL tree. Is this an AVL tree? Yes, because the balancing factor of this node is 0. The balancing factor of this node is -1. Okay, that is 0. Left subtree, no left subtree, so 0 minus 1. So it is 1 actually. 0 minus -1. That's actually 1. It's actually 1. 0 minus -1. Height of left subtree minus height of right subtree. So 0 minus -1 is 1. It's also okay. It's also okay. So this is also BST. So surely this is an AVL tree. Now we want to insert 20 into this AVL tree. Okay. Now just concentrate on this, how we can do it. We want to insert 20. Okay. Where we will insert? Where we will insert 20? We will insert 20. Where we will insert 20? Basically, this is a BST. So we will start from the root. Okay. 20 is greater than 10. So we will reach at 30. 20 is less than 30. So we will place 20 here. Okay. That is, insertion is similar to the BST. Okay. So it's a very simple procedure. We will start from the root, compare it with root. If it is greater than, then we will take a right path, else left path. In this way, we will first reach here, then insert it here. Okay. Now we check the balancing factor of each node. Okay. So I'm here. I given value x. Okay. 1 minute. Okay, I node here. Okay. Now what I want to do is that I want to check the balance factor of each node. So I calculated the balance factor of 20. It is 0. Then I calculate the balance factor of 30. It is 1. It's also okay. Okay. Next, I calculate the balance factor of this node, 10. But actually the balance factor of this node now. Actually, what is the balance factor of this node? I written it is -2. Actually, it is not -2. What is the balance factor here? Height of left subtree is 0 minus, what is the height of right subtree? Okay, 2. Okay, 0 minus 2. Yeah, it's -2. Okay. 0 minus height of right subtree. So -2. So the balance factor of this node is -2. Okay. So what happened is that because of this insertion, balance factor of the parent, one of the parent, this is actually the grandparent, one of the node is changed. Okay, so we should do rebalancing. Okay, so what I done is that first I checked what type of imbalance it is. It is an RL imbalance. Why it is an RL imbalance? Why it is an RL imbalance? I defined the imbalance as RL. What is RL type? Why it is called RL type? Okay. So what we want to do is that, 1 minute, we should go from this node to this node. This is the imbalanced node. Okay. Then, for example, we'll follow the path from this newly inserted node to the imbalanced node and find out how this imbalance came. So what I had done is that I given this node, imbalanced node as set. I taken this node, imbalanced node as set. Okay, set. Then this child, this node is inserted here. So I will follow this path. Follow this path, and I return this node, imbalanced node as set. Then in this path, the child of set is y. I marked this also. Okay. Then I want to find this path, child of y is x. I marked in this way. So basically, this imbalance is, this is the right node of set, and this is the left node of y. So this is called RL imbalance. This is called RL imbalance. That is, because of this insertion, this is the change. Here, change occurred, imbalance occurred. So we will start from this path, this node, newly inserted node to this imbalanced node. Then we will do this procedure. Okay, then anyway, this is RL imbalance. So what we will do if an RL imbalance occurred? What we will do if an RL imbalance is occurred? That is the next question. Okay, so if an RL imbalance is there, we will perform right rotation of y. Okay, if it is an RL imbalance, we will perform two rotations to rebalance. One is the right rotate y. That is, we will right rotate this node y. What is y actually? Child of z. Okay, we will right rotate y. So what will happen is that we will right rotate z means this 30 will go in this way. Okay, this is right rotation. So 20 will come here, 20 comes here, and 30 comes here. 30 comes here and 20 comes here. Then we can mark this is now. This is actually z. Okay, this is z, this is x, and this is y. This is y. This is y. After performing this, we again perform a rotation. Left rotate z. Left rotate z. So what is left rotation? This is the result of left rotation. We rotated this in this direction. In this direction. So M will comes here, 20 here, and 30 here. So basically, you should understand this procedure. So first you take if there any imbalance. If there is an imbalance, then you should find out which type of imbalance. Then you should perform right rotation, perform actions. Okay, you should take some actions to rebalance it. If it is an RL imbalance, first we want to perform right rotate Y, then we want to perform left rotate Z. Then we will get a tree like this. This is the tree. It is a AVL tree. So this is the basic concept of rebalancing. This is the basic concept of rebalancing. Okay. Next, we are going to the method. Okay. So next I am discussing the algorithm. So insertion method. Let newly inserted node be W. Okay. Let newly inserted node be W. Now, second, starting from W, travel up and find the first unbalanced node. Okay. So, you can check this example. So, try to understand how the insertion is possible. First, I want to insert the node. Here I am inserting. I am finding the proper place to insert it. Then I insert the node there. Okay. Then what I will do? Then you can check this algorithm method. Starting from W, travel up and find the first unbalanced. Travel up and find the first unbalanced node. Okay. So we should travel up from this node. Travel up from 20 and find out the first unbalanced node. So this is the node. Okay. So I am marking this node as Z. Try to understand the procedure. Okay. So this is the procedure. Okay. Starting from W, travel up and find the first unbalanced node. Let Z be the first unbalanced node. Okay. Let Z be the first unbalanced node. Now we want to find the Y. What is Y? Y be the child of Z that comes on path from W to Z. What is Y? Y be the child of Z that comes on path from W to Z. This is a very important point. What is Y mean? Y be the child of Z that comes on path from W to Z. Which means, you can check here. So what is Y here? What is Y? Y is 30 because we moved in this path. Okay, so in that path, child of Z, that is Y. Okay, I marked it as Y. Okay, similarly, next I want to find out X. Okay, so Y. Similarly, find out X. X be the grandchild of Z that comes on from W to Z. Okay, that is grandchild of Z that comes on path from W to Z. So this path is very important. This path is very important because this is the path we are following. So in this path, grandchild of Z is X. Okay, so Y and X, very important. What is Z, what is Y, what is X? Okay, Z is the imbalanced node. Y is the child of Z which comes in this path. Okay, similarly, X is the grandchild of Z which comes in this path. Then that is the first part of this algorithm. That is the first part of this algorithm. That is the first part. So this is the second step. Then third step, rebalance the tree by performing appropriate rotation on the subtree rooted with Z. Next, we want to perform rebalancing operation. Okay, then there are four possible cases. There are possible cases that need to be handled depending on X, Y relative to Z. That is, there are relative to Z, depending on the position of X and Y relative to Z, we need to handle four cases. One is called LL case. Okay, what is LL case? Second is LR case. Third is RR case. Fourth is RL case. There are four types of rotations basically, depending on the position of X and Y relative to Z. We can discuss that. One case is, for each case, appropriate rotation need to be applied. For each case, we need to apply appropriate rotation. Okay. So, first case is LL case. So, what is LL case means? You can note Z here. You can note Y here. You can note X here. So, basically, this is Y is left to Z, X is left to Y. So, this is called LL case. If it is an LL case, then we want to perform this operation, right rotate Z. Okay, that is, we want to rotate this. Okay, so Z will come here, Y will come here, X will come here, and the subtrees comes in this way. Okay, that you should be studying. Next, what is LR case? Z is here, Y is here, Z is, Y is left, and X is right. X is right. X is right. So this is called LR case. If in this situation, we need to first perform left rotate Y. First, we want to perform left rotation of Y based on the Y. Okay, left rotation based on the node Y. Then we will get a tree like this, Z, X, Y. Okay. That is, we want to perform this. We want to perform this. Then Y will come here, X will come here, and in this way it will come. So after that, we want to perform right rotate Z. Okay, we want to perform right rotate Z. So this is Z now. We want to right rotate this. So Z will come downwards. So the resulting tree will be like this. Z will come here, X will come here, Y will come here. On this, we will perform the right rotation. And the third case is RR case. Z is here, Y is here, that is right, and X is here, which is also right. So we will perform left rotation. That is, we will rotate this in this way, about Z. Left rotate Z operation is performed. The resulting tree will be like this. Next, we want to check this case, right-left case. So Z is the imbalance node, Y is the child of that imbalance node along the path, and X is the grandchild of Z in this path. So what we want to do? We want to, this is what type of imbalance? This is called RL imbalance. This is R, this is L. If it is an RL imbalance, first we want to right rotate about Y. Okay, then we will get a tree like this. Like this, we will get a tree. Then we want to perform left rotate Z. Then we will get a tree like this. So this is the basic method of insertion into a AVL tree. So next we can discuss some examples. So the basic concept is okay. Now next we can discuss an example. Okay. So this is the example we need to consider. First we want to insert 14. So 14. Okay. Next, and I want to insert 17. So 17 is greater than 14. So I inserted here. Then I will check the balancing factor of each node. Here the balancing factor of this 17 is 0. This is 0 minus 1. 0 minus 1, which is equal to minus 1. So this is an AVL tree. So next we want to insert 11. Where I will insert 11? I will insert 11 to the left of 14. Okay, so I inserted here. This is also an AVL tree. That satisfies the AVL tree property. Next I want to insert 7. Insert 7. Where I will insert 7? 7 is less than 40, so I comes along this path. 11 is less than, sorry, 7 is less than 11, so I comes and insert it here. Then this is also an AVL tree. Then balancing factor of each node is calculated 1 1 0 0. Okay. Next is 53. Where I will insert 53? From the root I start. 53 is greater than 14. Then I comes along this path. 53 is greater than 10. So I comes along this path. Then I will insert it here. Then I will calculate the balancing factor of each node. Here, the balancing factor of each node is having value 0, 1, or minus 1. So this is also okay. Now we can consider insert 4. So how can insert 4? Where I will insert 4? We can check. So insert 4 means where I will insert 4 in this case. So 4 is less than 40. So I comes along this path. Then 4 is less than 90. I comes along this path. 4 is less than 7. So I comes along this path and I insert it here. Okay. Then I will calculate the balance factor of each node. Here it's okay. Here it's okay. But there is an imbalance. Okay. This is an imbalance. Here the balance factor of this node is 2 minus 0, which is 2. So how we will handle it? Okay, how we will handle it? So this is actually I'm handling in this way. Okay, I inserted the node 4 here. So I moved upward and find this is the imbalance node. So I marked it as set. Okay. Now, because of this insert, this imbalance is coming. So this is the path. Okay, you can note this path. Hmm? You can note this path. So in this path, what is the, so set is this, and this is the path. This is very important. This is the path. Okay. In this path, who is the child of set or 11? 7. So I marked it as Y. Okay. Then in this path, who is the child of 7? It is the left child, and I mark. Okay. So I got these three. Now I want to check which type of imbalance it is. Which type? LL. Why? Because this is left, this is left. So this is LL imbalance. So as our rule, we want to perform right rotation about the point set. Okay, we want to perform right rotation about the point set. So what will happen is that we want to rotate this subtree in this way. Okay, so you can check here. What happened is that 7 is moved here, 11 is moved here. Okay, just simple. This 11 is moved in this way, 7 is replaced there and is moved there. Okay, then I will calculate the balancing factor. Okay, so this is the balancing factor of each node is 0, 1 or minus 1. So this is an AVL tree. So this is the way to handle the imbalance. Okay, insert 4. Next is insert 13. Okay. Anyway, I think time is over. So please give the attendance.